Welcome to this tutorial for Cisco Cybervision. In this tutorial we are going to cover the different capture modes of a sensor and how to apply traffic filtering. Cisco Cybervision leverages a unique two-tier architecture consisting of edge sensors and a central platform, called the center. In a typical scenario, many sensors will analyze network traffic passively and send the results of the analysis to the center. The center will process the inbound data, augment it further and provide access to the user and for integration into other platforms. Cybervision has flexible options for deploying its components. The center can be deployed on hardware-based environments, such as the UCS M6, but also leveraging virtual environments, like Amazon AWS or Microsoft Azure. The sensor application can be deployed on any of the listed examples out of Cisco's hardware portfolio. In addition to that, Cybervision offers deploying its sensor as a Docker-based application to any industrial compute that complies with the technical requirements. Independent of the deployment scenario, you might have a requirement to filter the inbound traffic on the sensor side, and only process a certain part of it. That's where the different capture modes of the sensor, as well as its capability to apply traffic filter, become important. There are two main options. You could change the capture mode of a sensor. Please understand the capture mode as a predefined network traffic filter. Or you could create your own filter rules and apply them to any of your sensors. Both, changing the capture mode and applying a traffic filter rule, can be done via the user interface, or in a programmatic way by, for instance, using Ansible. Let's start with the user interface. This part of the tutorial presumes that you are managing your sensors using the sensor management extension of Cybervision. If you don't yet know about the sensor management extension, I recommend watching the corresponding tutorial video. Start by logging into your center and navigate to Admin in the main menu. Select Sensor, followed by Sensor Explorer in the context menu. You can see a list of the sensors connected to this center instance, their operational status, and their software version. Select one sensor. You will be provided with additional information in the drawer. Click on Capture Mode. This UI is sensor instance specific. All changes you apply will be only applied to the sensor you selected before. You can see different options. The selected default is optimal, meaning only the most relevant flows are being analyzed. This setting excludes multicast traffic on the capture interface of your sensor. The All option would not apply any filtering at all. The Industrial option would focus on specific industrial protocols, such as Modbus, CIP, and OPC UA. For further information about the predefined filter, please refer to the Cybervision Architecture Guide. The last option allows you to specify custom rules following the TCP dump syntax. Select this option. The allowed syntax is documented on tcpdump.org. For this tutorial, let's provide a simplistic filter, which only excludes traffic for one specific IP address and port. This filter excludes all traffic related to this IP on port 161. Click on OK to confirm. Once your filter is saved, click again on the sensor and check the information provided in the drawer. Note the changed capture mode showing the filter we just defined as being active on the sensor. This sensor is now actively filtering and in this particular case ignoring this traffic. This configurational change can also be done entirely on the command line. Connect to your device hosting your sensor application. In this example, we are connecting to an IE 3400 via Secure Shell. Send the enable command and authenticate your request. List the installed application. Locate your sensor and confirm its operational status to be running. Connect to the running instance of your sensor. You can find the filter setting of your sensor in its configuration file. Note that the filter is set to the value we just submitted on the user interface. You can set the filter by simply editing this file, but also via toolsets allowing to do the same at scale. For instance, by using Ansible. Keep in mind that the filters used in scaled production environments are usually larger and more complex than in this example. Thank you for watching this tutorial about the different capture modes of a cyber vision sensor and how to apply traffic filtering.